Okay, so these are different chart types in R programming, and this is a little bit different from it's a little bit different from data visualization, which is a whole topic by itself. Here, we just want to look at just a semblance of how to be able to visualize your data. So, so maybe let me just show us something. So this is just one. So this is a data we just visualize momentarily. So how do we do all these things? Do some of these things. Okay. And then, of course, we check another one here. Yeah. There are quite a series of them. How do we... So today I'm titling it, what is it? We have the chart types, and then we have the going to be looking at chart types and then plots in R programming. So the first one is pie, and then I'm picking it from here. Let me be using this. I just give you the syntax, and then you'll be able to make sense from it. So we set it here. So if you want to plot something like pie, this is the syntax. Just going to copy that too. So if I come to this place, so the syntax is that you have pi. First, the X here represents the data, followed by the labels. You have radius, main, color, and then this. So sometimes it's good if you want to create it, then you can have your data here. So I decided to create this particular data, or create this particular vector, and I call it population. And then so you have it over there. Then you can create labels. You create labels. So if I come here and then I run that particular line, I will just plot only a pi, and then of course, so you can see the pi here, but it doesn't carry any meaning. Okay, so let me close it. So what you normally do is you add labels to it. So decided to write the labels. You can use your vector to create a label and then add the labels to it. So we created a vector of labels. Make sure that the argument you enter in the data, if the data points are, let's say 1, 2, 3 up to 10, the labels must be 10. So when I run that, then I now plot it, you see that it now comes with labels. So you can see that the chart is now having different labels and in that order. So we can add a title to it. The title is where you use main. You see, so we have the data followed by the labels, followed by main, and the main you give it like main is equal to, then you put it in this, run it. So you can see that the chart is now having everything that I'm talking about. The same way, you can add a title. You could also do, this is an exercise that I want you to do. So we just create a salary of 5 workers. These are the names of the workers. I think I should put this in capital, like this. So you can use a pie chart to visualize it. So the first argument, you use the pi function. The first argument is salary, followed by workers. You have already created the workers' names. That become the labels, which will be labeled with the workers and their names here, main on this place. So if you run the whole thing like this, you just highlight the whole thing and run it. You are going to have, zoom it out, you can see that you have salaries of Ghanaian workers, and then how you present it on your pie charts. So we can go on and add different things. We can add colors to it. We can specify colors the way we want it, but you can do that at your own time. Now, plotting a bar chart that we have here, the syntax is what you are looking at here. You can pause the video and then have a clearer look at the syntax. Syntax is that you have the bar plot function followed by the first argument, which is here h, represent what we call the data. You have your x label, the y label, main, and then in that order. So let's pick the data we are having here. So we have bar plot, then we put the population. This is the population, is the one that we the data we created here earlier, which is here, as you can see. So we come here and put, so we have our x label, villages, y label, population, the main, that's the title of the graph, and the name dot argument. So let me plot this particular one first. And so you see that when you have the plot like this, because you do not put name dot argument, so here we don't know what this bar represents. So if you want the bar to have names, you have to add the argument name dot argument here. So name dot argument is equal to, if in that case you would have already created those names and then you put it in this vector. And so in those names we have created and called them labels. That's what we have put here. And then so if I run that, you see that the graph will now have names. As you can see, it's happening over here. Najong, Gilik, Kote, and then in that order. So this is how we are able to plot a bar graph. You can also plot the bar graph using the data, inbuilt data. So there's an inbuilt data set in R called Iris. So, but we are not interested in all of them. So you just put bar plot, put the name of the data set, which is a data frame. But because you are not interested in everything in the data frame, you are going to put 1:10. Then select the column. So this is column 3 of row 1 to 10. That was going to form your data. Your name dot argument is going to be this. So if I run only that, it's going to print it for us. So you can see. So this is quite simple, because here our name dot argument, we are going to pick the names from that particular data, and that data set has a column that contains names. That column is column 5. That's what we put here. But in column 5, are we picking all the names? No, we are picking the first to the 10th name. So that's where we have 1 to 10 of this particular data. So here is the data. Then you pick the first name to the 10th name. That's row 1 to row 10 of column 5. And that's all. And that is going to form your name dot argument against the data point you have created here. So you see the data point, we are picking the data point 1 to 10 of column 3. Okay. And then in that case, then we are also using column 5 to be able to make sure that we name them in that order. And so that's what we have here. We could have added color to it. So the same thing we want to repeat. So you see that now we've added the labels to them. We have the X label and then the Y label sizes, then in that order. If you print it, it looks way better now. This is how to be able to print it. So as you can see, so the next thing is to plot a box plot. In box plot is like a box plot is used to show data distribution. And then in data distribution, we use an inbuilt data set called MTCAS. So let me clear the console. There's an inbuilt data set in R called MTCAS. Let me look at the first 6 lines or the first 6 rows. You can see this is how the data looks like. I'm not going to print everything. So in that particular data, we want to just select, in plotting a box plot, you need to have a dependent variable and an independent variable. It's not only in box plot, but in other plots, you can equally do that. So here we are looking at, there are different brands of cars, and they have the miles they each cover per gallon. And then you want to find out whether, if you pick miles per gallon as a dependent variable, how is it explained by the cylinder size of the car? And so that's what we have here. So when you use this tilde, it means explained by. And so where are you getting the data from? So here is a column of miles per gallon, and here is also a column of cylinder sizes found in the particular data set called MTCAS. So this is what you normally do. So when you use the function, you have to create the formula. So the first argument is formula, and then followed by the data. So maybe let me print this out, and then you'll be able to see what I'm talking about. We're looking at box plot, yeah. And so the box plot let me copy this and take it to, sorry, let me do undo and copy it. And then if I take it to my RStudio box plot, always I have my syntax here, and then put it here. So the syntax is saying that when you put the function box plot, the first argument is always a formula, which is x. So maybe I should write the formula. Then followed by the data, followed by the notch, then the var with names, and then whatsoever. This names here is the same thing as name.argument in other functions. Remember, each function or each plot type has the syntax it follows. So in terms of bar plot, we call it name.argument. In terms of box plot, we call it names, and that's all. So this is what we are going to do. So we come here, the whole of this becomes our formula. So the formula here is mpg tilde cylinder. So we are saying mass per gallon explained by cylinder size, and then we follow by data. Data, we say empty cat is our data. So if we don't add anything, we do like this, we're going to plot, we're going to have our box plot. And so you can see how the box plot looks like. It's really simple. Okay, so that is it. So we can add other things to it. Here we are saying that apart from that, we can have x label. We label the x side as car and the y side as what the, so as you see, we have added y label and then the x label cars and then mileage. We can add other things if we so desire. So here we've decided to add colors, and then in that order. And then because we are adding more than one color, when we say color is equal to, we have to make sure that we use a vector or the combine function to put more than one color, and then we give it accordingly. So it will color them according to how we have put it here. And then that is how we plot a box plot. I'll be doing data visualization, so that is when I'll be interpreting the graphs for you. Now, plotting histogram. Histogram is, like I said, box plot is used to show data distribution. Apart from that, it also indicates outliers and skewness of the data. Skewness is the same thing as the data distribution. Is it skewed to the right, skewed to the left? Does it have outliers? And then which part of the data or which section of the data is within 75th percentile, 25th percentile, and the median? And where is the median tilted to? If the median is up, it means the data is right skewed. If it is down, it is left skewed, then in that order. Okay, so we are also here, we are going to look at how to plot histogram. So in histogram, this is the syntax. Always follow the syntax. The function is histo, followed by v is your data. Main give you the title, x label, then what it gives you the x label. You can have x lim. I don't want to discuss this one. The x lim is sometimes you have data that the size of the data or the data point size are too, so you can give a limit to the x size and a limit to the y size. Say that, okay, the last number or the last should be this, so you are giving a limit. The breaks are always there to tell you the chance. Remember, histogram is used to group data. You put the data in group and then you or it groups the data and to visualize it. So let's say we are creating a data point, 100 data points of ages of students. The lower age is 18 and then 35. We run that. I will put it in this variable called age. So if I run histogram right now, histogram will just print it out, and let's look at how it looks like. So this is how it looks like. So here you can't make any sense with this. You just have ages and then we have frequency. How it is grouped, you don't have an idea. So when we can add titles to it. So I have title, the title, you say main, and then you type the title in double quotes. And so you can see ages of students of KNUST. So I just put that out there. You can add color to it. And so here we have decided to add the Y label, the X, and then we have. So if you run that line, you can see that we now have Y label, X label, then title. Here we can add color. So and then add breaks. The breaks actually say, all right, we have ages of students from 18 to 35. So how do we want to group it? We want to group from 18. If we say breaks 5, it means that it will group from 18. It will group the first, let's say 20. It will group them in five groups. Okay, it's going to look at the entire data and group them into 5. And that's what it says. If you say breaks 6, it's going to be 6. It will group the data into 6. If you say 10, it will group them into 10 groups. The data is going to be in 10 groups. Let me put it that way. So now, if you're also going to give it a color, and you want the colors to be according to the groupings. So when you say breaks 5, you have to give 5 different colors using the combine function. I've already explained that. So if I run that, this is how we have grouped the data into 5 because we gave breaks to add 5. So if I pull that out, then you see that it's going to be like that. So it has grouped the data from 15 to 20, 20 to 25, 25 to 30, and 30 to 35. So this is how it has grouped the data. So this is how we visualize histogram. It's very useful. You can try it wherever you are. Now, the next plot that we were supposed to look at is, we looked at box plot, we looked at histogram, then we look at a line graph. A line graph is used to show trend. It's basically for trend analysis. So if I come to my RStudio here, I'm just going to say, what is it? Plotting a line graph. A graph like this. So obviously my syntax is already this. You have this, your V is actually your data, and the type will tell you whether you want it to be point, you want it to be a line, you want it to be dashes. Then you have your color, you have your X label, and then your Y label. So now let me say that what is it? I have this. What is it? I'm going to copy this and come here. I'm going to create a data. What is it? VV, or let me just say height. So height can be a continuous variable. So it's good that way. And height, I just do this and then come and put this. Here, I want to remove the round function. And then here too, I want to say there are about 100 points, right? 100 point variables. So, and I want to say, I want it from 3 and then to 35. So that way, when I run that, I have my height already there. So now, without anything, I can just come here and say plot. If I say plot and I put the height, height like this. I don't know if my height is not well spelled. And then I add type. So the type here, if you put O, I'm going to put O there and then run it and let's see what's going to happen. I need to put O in double quotes. Or is it 0? Yeah, so you see that if I pull it out, so look at how the data, look at how it looks like. So there's actually no trend in that data. You can see it's just zigzag, just going. So the lines are joined by points. And then we could have added color to it. So if I do just copy here, then I'll paste it again. And then in that case, after here, comma, then I'll say color. And then I'm just going to say green. So remember, colors are always written in lowercase. So when you run it again, now the plot is now green. Then you've added color to it. Of course, we can add labels just like the way we had labels earlier. And that is quite simple. You have your X label. And then, of course, your X label, you are just going to say, well, what is there? We are looking at ages or height. So I'll just put here height, maybe height of students. And then my Y label is actually going to be the height itself. But you see that even without me doing that, it automatically even gave those things there. But now when I do, it will properly label the graph for me. you can add main as your title of the graph. So you can see height of students, and then the height is, or you could have, maybe here could have been a different thing, or names of students or something like that. So it's just an example I just gave. So this is how we plot a line graph. And then let's get back to this place and then look at something. The main is where the title is. Now plotting line graph, so we could have used this. What is this? There are instances you may have to you may have to this one I just use only one variable. See V, and I say type O, and then color red, and then whatsoever X label month, and then rainfall. So I could add another line to it, and then you look at how that line is going to look like. So if you want to plot more than one line, you just add something we call lines, and then you should have that data also seated somewhere. So if I want to add a line to this, another line to that, then I could just come here and then create another one and say maybe that one will be height underscore, let's say lecturers. Maybe so want to superimpose the height of lecturers as against students. And so when I come here, I'll create that vector. And then that vector, what am I going to say? Maybe I could just sample, or I could use the same run if, because it's a random listen. Because it is random, it will not be the same. I'm just going to copy that, come here and put I'm just creating so I'm going to run the same 100 people. Then I come here, but this time around, I want to say that the minimum should be 6, and then the maximum should be 40. Minimum 6 and the maximum, let's say 50. And then you run that. When you run it again, then right after, so now that this plot is already there, all you need is to just come and write lines. Lines like this, lines become a function. Then you put height of lecturers, H underscore lecturers like this. And then what type? Then you say type. If you put type L, then my type is going to be L. That means it's going to be a line. And then what color should I give to that one? Color should be equal to, let's say, blue, so that to separate that from the, so it will superimpose that line on the one that is already there. So you notice how it is. So now we have students versus lecturers, and that's how we find trend. And then we can add another line. You can add another line as much as you can. Now the last plot I want to show us quickly before I go is, this is how to plot lines. It's used for trend analysis and then modeling. So there are quite a number that I'm unable to. Always pause the video, and then you can have a clearer view of whatever I have here. You see, look at the syntax. You can pause the video, then you look at it. Then the next thing is a scatter plot. A scatter plot, that one, the syntax is also here. I'm just going to copy that. Then, so here, what am I doing? I'm going to plotting what do we have? Scatter plot, scatter graph or something. Then when I come down, I'm just going to put the syntax here. So I have hashtag. I'm going to have a hashtag because it's, and so the syntax is always, so you use plot function to be able to plot a scatter. So here we have our X and we have our Y, we have main, then, so here we need two variables. We have X and Y, main, X label, Y label, and then in that order. Now, let me get back to this and you look at it. X is the data set whose values are the horizontal. Y then it's just like when we used to plot ordinary graph where 2 and 4 meet, then you mark over there. Where 6 and then the 5 meet, then you mark it after that. You rule a line. It's the same thing we are going to do here. So we must have two vectors, that's x and y, but it can be anything. So here, to make it simple, I'm just going to say plot, and then in that case, I'm going to use the height data I created earlier, which is here, comma, then it will be followed by the next one, that's for the x-axis, and then for the y-axis, I'm taking the ht underscore lecturers, which is also here. That is how I am supposed to look at it. So for at the moment, it will just if I don't add anything, it will create a scatter for me. And look at how the scatter, there's no pattern. There are instances the scatter plot can give you a pattern. This one, there's no pattern. Yeah, so I could have added color to it, or I could have added type. Then let's look at the syntax once more. Here I can have title, I can have x label, y label, and then maybe axis indicates whether both axes should be drawn on the plot, and then in that order. So here I think that's basically all that you need to do is the x label and y label. The x limit and y limit, I have not touched on that, because when I'm doing data visualization, I will explore that in details. So this is how to plot this is the simplest way to plot your scatter plot. Sometimes too, you could actually use the same function called scatter, like something like scatter smooth, and then I will just put the two data points there. I'm going to have height, which is here, and then ht underscore lecturers, which is also there, and then do this. So this way, it tries to look for the trend. So you can see a line has been drawn in the middle because I used the scatter smooth. So this becomes your model. And you notice that there's actually no correlation between, it's just smooth as to whether when lecturers are growing taller, are students also growing taller? No, there's no effect. Because here, if you look at the slope, is 0. So there's no effect at all. The slope of the graph is 0, no effect. And so that's what it means. It's not directly, it's not indirectly. So what the growth of height, the height of lecturers has nothing to do with the height of students. That's basically how to interpret this. So this is how we are able to look at what is the scatter plot. Then I don't know which plot is left. So that is it. There are quite a number of plots that I'll be looking at when I start data visualization. And this is just a way of like introducing you into something that is yet to come. Data visualization, I'm going to use ggplot2, and then we will come up with very fascinating plot types that you'll be so amazed, like trees, and then models that has to do with stack bar plot, group stack bar plot, what is it? All these models that you are looking at, we'll see how to generate them when we are dealing with ggplot2. That is under data visualization. But for today, thanks. If you enjoy my videos, why don't you share, and then I also recommend for others to join. My name is Biba Bright, and always a pleasure doing these basics of data science. I leave it here. Bye-bye.